Hello friends. Welcome to Brother Coaching Guys. Today's topic is impulse. In this lesson you will learn about the concept of impulse and how you can apply it to a variety of interesting situations. You will learn about the relationship between impulse and momentum, and how to calculate impulse through a variety of examples, and some real-life application of impulse. So let's get started. Suppose, if you've ever kicked a ball, hit a punching bag, or played sports that involved any kind of ball, you have been using the concept of impulse without even knowing it. So what exactly is impulse, and what does it have to do with any of those situations? Before we can define impulse, we need to talk about the concept of momentum. If you want to learn the concept of momentum, watch my videos. What is momentum and law of conservation of linear momentum? I will give you links in the description box. Without knowing the concept of momentum, you does not understand the concept of impulse. So watch this videos. Here I'm simply tell what is momentum. Momentum is a measure of strength, and a measure of how difficult it is to stop an object. The formula for momentum is P is equal to mass times velocity. So momentum depends on mass and velocity of an object. So, an object that is not moving has zero momentum because of its velocity is zero. So its momentum is zero. A slow-moving large object has a large momentum because of its mass is more, then its momentum is more. Or, a fast-moving small object also has a large momentum because of its velocity is more. For example, if a ping-pong ball and a bowling ball have the same velocity, but the bowling ball has a greater momentum because it is more massive than the ping-pong ball. Momentum is a vector which is equal to the product of mass and velocity, which is also a vector. But how is momentum related to impulse? When a force acts on an object for a short amount of time, impulse is the measure of how much the force changes the momentum of an object. The formula for impulse looks like this. Impulse is equal to force multiplied by small time. Or in the symbol representation, impulse is equal to F multiplied by small time delta t. This impulse is a measure of how much the momentum changes as a result of force acting on it for a period of time. An alternative formula for impulse looks like this. Impulse is equal to change in the momentum, that is delta p vector. This formula relates impulse to the change in the momentum of the object. Impulse has two different units, either kilogram times meters per second, kg meter per second, or Newton times seconds, ns. Let's take a look at a few examples. In this first example, we'll look at the impulse for an object that collides with a wall and stops after the collision. If the 2.0 kilograms object travels with a velocity of 10 meters per second before it hits the wall, then the impulse can be calculated using the formula. Impulse is equal to change in momentum. In the second example, we'll look at the impulse for an object that collides with a wall and bounces back after the collision. If the 2.0 kilograms object travels with a velocity of 10 meters per second before it hits the wall and a velocity of minus 10 meters per second after the collision, negative because it bounces back in the opposite direction, then the impulse can be calculated as follows. In this next example, we'll calculate impulse a different way. What is the impulse caused by an average force of 10 newtons? if it acts on a ball for 2.0 seconds? The impulse here can be calculated as. Now that we can calculate impulse, we can take a look at some interesting examples of impulse in everyday life. The most notable example is the car airbag system. Airbags are in cars in order to reduce the damage to a driver or passenger during a collision. If impulse is force multiplied by time, then force is impulse divided by time. What the airbag does is increase the time required to stop the momentum of the passenger or driver. If this time is increased, then the force of impact is decreased. If the impact time is short, then the force of impact increases and may cause severe damage to the occupants of the car. Having padded floors at a gymnasium is another application of the concept of impulse. In order to reduce the force of impact, when someone lands on the floor, the padding increases the contact time between the person and the floor. So just like the airbags, when the contact time increases, the impact force decreases. Here is an example you can do at home. You and your friends want to experiment with impulse and eggs. If you drop the eggs onto a hard surface, you all know that the egg will break. The impact time between the floor and the egg is short, which means that the force, which is impulse divided by time, becomes large enough to crack the egg. If you have 4 of your friends, hold a bedsheet a few inches above the floor and drop the egg again. The egg does not break. Why? The bedsheet increased the collision time, and as a result, the force of impact was reduced. Impulse is also ever present in sports. In tennis, whenever a ball is hit back and forth, there is impulse between the ball and the tennis racket. In football, when a ball is punted, impulse can help determine the force of the kick, if we know the contact time between the foot and the ball. In tennis, baseball, and golf, among other sports, the faster you swing at the ball, the greater the impulse you impart on the ball. The ball then goes faster or further away. Hope you understand, guys. What is impulse? And the relationship it with momentum? With lots of examples. If you really like it, please share it with your friends and comment on it. And please subscribe to our Brother Coaching channel for watching basic science videos and more. You can follow me on social media. On my Facebook page, www.facebook.com/brothercoachingcenter. On Instagram, www.instagram.com/brothercoaching. Thank you so much guys for watching this video. Bye guys.